So we're going to be factoring, but a lot more than what we did with quadratics. So we still will be using what we did in Unit 5 some, but we're going to learn more. And the first part, we're just going to go over GCF a little bit. You should be good and familiar with GCF. So GCF, we're looking for the number that goes into both 12 and 10, the largest number. And then we see how many variables we can divide out. So what is the GCF of 12 and 10? 2. And then x cubed and x squared. What's the GCF there? It's x squared. You can factor out, you can divide both of those by x squared. And if I divide both terms by 2x squared, this first one we're left with 6x, because 12 divided by 2 is 6. And then x cubed, when I take out x squared, I'm left with x. Plus 10 divided by 2 is 5. And I took all of the x squareds. So when I factored GCF, I have 2x squared, and then I'm left with 6x plus 5. Number 2, what do 14 and 7 have in common? 7. And then how many m's can I factor out? 2. I can't have any more than this squared because this term over here doesn't have any more to give. And then the n's, how many n's can I factor out? How many n's? 5. You always factor out whatever the smallest exponent is, that's what comes out. So then if I divide 14 by 7, I get what? 2. How many m's are left? And in the ends, we took them all out. Minus 7 divided by 7 is just 1. We started with m squared. I factored out m squared. And into the 9th, I factored out into the 5th. So how many n's are left? 4. And really, you don't have to put that 1. Every time you factor, you need to look for a GCF. See if there's anything they have in common. Sometimes you can just pull a variable out. Sometimes you can just pull a number out. Sometimes you can factor out both. So make sure you always look. We're going to do difference of squares, which you may be a little familiar with because we've talked about it on our Bank 20s. But difference of squares is when we have 2 terms. If I look at all of my examples here, every one of them is 2 terms. You can only do difference of squares with 2 terms, and both of those terms have to be a perfect square, and there's a subtraction between them. That's why it's called difference of squares. 2 squares that are being subtracted. In order to be a perfect square, if you have a variable, your exponent must be divisible by 2. If your exponent is divisible by 2, it's a perfect square. So I want you to go down the side and fill in these first few blanks here. You should have these perfect squares memorized. You should know them. So whenever you see these numbers, It's a perfect square. That's your hint. We might have difference of squares. Now with the variables, as long as it's an even number, it's a perfect square. The actual exponent itself does not have to be one of these numbers. It just has to be even. So the square root of x squared, to take that, we divide the exponent by 2. So it would just be x to the first, or x. The square root of x to the 10th would be x to the 5th. What's the square root of x to the 16th? X to the 8th. What about x to the 38th? X to the 19th. If you recognize that you have two terms that are perfect squares and there's a subtraction, it's a difference of squares. And here's how you factor it. Let's say we have a squared minus b squared. So my two perfect squares with a subtraction. It's a plus b, a minus b. So we take the square, if we take the square root of each side, we get a and b. And then we write a plus b, a minus b. So for example, my a is going to be the square root of 49. So to get my a value, take the square root of the first term. And what is the square root of 49? 7. B is going to be the square root of x squared. You don't put the negative down there with it, just the ends. What's the square root of x squared? X. And when I write my factors, I write 7 plus x, 7 minus x. You have to keep it in this same order. You don't put the x first. Put the 7 first. Number 4, I didn't tell you, we didn't look for a GCF there, but there wasn't one. Is there a GCF in number 4? Anything that x to the 10th and 100 have in common? Well, this one's not written with the exponent of 10, so as long there's no x's. This one doesn't have an x, and there's really nothing we can divide it by. So, like down here, we have numbers in the front. They possibly would be GCF. So up here, nothing to divide out. So my a, I take the square root of x to the 10th, which is what? X to the 5th. And my b is the square root of 100, which is 10. And my answer, x to the 5th plus 10, x to the 5th minus 10. If you write the minus first and then the plus, that's okay too. But the numbers and the variables can't be flip-flopped. Number 5. Is there a GCF? Is there anything you can divide both 9 and 36 by? 9. Do they have a variable in common? No. One's x, one's y. So the only thing we can take out is a 9. And when we factor a 9, we're left with x squared. No, not x squared. X to the what? 6th. I'm so used to squared being there. X to the 6th minus what? 4y to the 16th. Good. So my a is going to be the square root of x to the 6th, which is what? x to the third. And my b is the square root of 4y to the 16th. So when I take the square root, take the square root of the number in front. What's the square root of 4? 2. And the square root of y to the 16th is y to the 8th. In your final answer, you have to always remember to bring down your GCF. So I have 9, and then x cubed plus 2y to the 8th, x cubed minus 2y to the 8th. Any questions? All right, number 6. Is there a GCF? 2. When I divide everything by 2, I'm left with x squared minus 16. A is the square root of x squared, which is what?
X.
B is the square root of 16, which is 4. And then I have x plus 4, x minus 4. Number 7, is there a GCF? 7. Anything else? They both have an x in common. And I can take out only one x because the 28 just has the one x. I can't factor out anything more than that. So when I factor out 7x, I'm left with x to the 6th, because 7 divided by 7 is just 1. And then when I take out one of those x's, I'm left with x to the 6th. Minus what? 4. 28 divided by 7 is 4, and then the x's, I took all the x's out. So my a is the square root of x to the 6th, which is x to the 3rd. B is the square root of 4, which is 2. So the final answer, we bring down the 7x, and then it's x cubed plus 2, x cubed minus 2. I want you to try number 8 on your own. All right, number 8, you should have factored out a GCF of 2x cubed. Both of those numbers are divisible by 2, and then we can take out x cubed, leaving us with 4x squared minus 9y squared. Any questions on how I got the GCF? So my a is the square root of 4x squared, which is 2x. B is the square root of 9y squared, which is 3y. Any questions on that part? So then you bring down your GCF, 2x cubed, And then it's a plus b, so 2x plus 3y, 2x minus 3y. Any questions? And I think we will stop there and do a Google form.